All right, welcome back to our next video. In this video, we're going to build a basic toon shader in our Unity shader graph. Now, this type of shader gives us like objects like cartoon or cell shaded look, and it does this by simplifying how light interacts with these objects. Instead of smooth shading, we're going to create color bands like you'd see in a comic book or animated film. And this is kind of a look that a lot of times they try to emulate in a lot of games and stuff. So last time, just to kind of briefly look at what we did is we just kind of learned how to create a custom function, how to create a shader, and how to hook it up to an object. Don't worry too much if it's still a little foreign to you when you go inside of here and you're not sure what all this stuff does. With time, I promise you it all becomes clearer. All right, so the first thing we're going to do, I mean, aside from like if you want to create a new shader, I'm just going to use this old one here, the custom world to color, and I could always rename it later, is we're going to simulate lighting. And we need two things to simulate lighting inside of our scene. First, we need the direction the surface is facing. So if I select this plane here, I'm just going to move my sphere out of the way for a second. If we look at this, we could see the direction that this surface is facing based on the y-axis here, right? So it's facing up. This one is also facing up, but it's got a lot more faces or a lot more geometry. So you can imagine there's a lot of different y-axis lines poking out of this. This is like one flat polygon of four sides or two triangles. And then we need the direction essentially that the light is coming from. So I'm going to hit F to focus on this light here. And you can see that you can actually see which direction the light's coming from by this highlight. So I can actually rotate this light a little bit. And I'm going to change this from pivot to center. And then I can actually change this to global. And then just to give me a little bit more control. But you could see here that this direction of this light is going that way. And if I go to local, you can see, I'm going to hit W here. This is the direction the light is, right? It's facing that way and it's hitting the highlight here. And also positionally, it's a little offset, and that's why you're seeing it more on that side. Now, what we're going to do is we need to compare these using something called the dot product, which tells us how much the surface is facing the light. So let me go ahead and just move these out of the way. And I'm going to just highlight that line and break it. I'm going to add something first. It's called a normal vector. So I'm going to hit spacebar, and I'm just going to start typing out normal. And actually, sorry, I have a recording thing open here, and it's in my way. So you can right-click, go to create node here. You can hit spacebar, which I like to do, and just start typing normal vector. And I'm going to grab this where it says input geometry normal vector. Now you'll see here there's different parameters. There's object view world. We're going to set our space to world. Now what this normal vector gives us is it gives us the direction of each pixel on the surface that it's facing. Remember I told you we need to know essentially what direction the pixels on our surface are essentially facing. And the next thing we need is we need to know the main direction of the light in our scene. And what's nice is they give us a node for that. So I'm going to just start typing main light direction. And this little node here actually gives us the direction of the light in our scene. So it makes it so much easier. In the old days, you have to use all this complex math to calculate where the light was coming from. The next is we're going to create a dot product. So I'm just start typing the word dot, and I'm going to add this. Now, again, what I want to clarify is what a dot product is. So remember, it compares the surface normal. So you can imagine the surface normal is this y-axis, to the light direction, which is here. So it's going to say, hey, this is facing up and this is coming at this angle, right? So here's our surface normal here. And we could see, again, because there's a lot more geometry on this sphere, we're getting a highlight here because we have a bunch of different surface normals coming off of our model, right? And so it compares them to. So what does it compare? Well, if you have a number, the number is 0 here, it's fully lit. That means the object is fully lit. If it's a 0, that means that just the edge is lit by the light. And -1 means the light is facing away from the model. So you can see here that we have because we don't have geometry here, if I was to take this object, hit Control D to duplicate it, and then I'm going to flip this. So I'm going to move it down here. Actually, let me just move it off to the side here. What -1 tells us is that the light is facing in opposite direction. So I'd have to actually rotate this. Let's see, 100. Oh, sorry, we want to do this on the x-axis. 180 degrees here. So now my surface normal is facing away from the light, and that's what -1 gives us, right? All right, so let's go ahead and just plug these into our dot product. Here we go. And now you can see that we're getting essentially this is a simulation here. but our main light direction is hitting it this way. And then this is our normal vector, which is our world. So the light is hitting this axis here, right? So when we attach this to an object later, this is, again, this is just giving us the positioning of our main light and our normal. And that's what our dot product is giving us. Remember, we have that value where we get three numbers, the 1, 0, really the gradation between 0 and 1, like of different number values. But this is going to give us where our light is hitting, which is what we need. Next, we're going to create the lighting bands, and we're going to do this through a method called quantize instead of setting up smooth transitions. And this is what actually gives us the two effect. So let's go ahead and add a multiply node here. So spacebar, just type MUL, and you'll see that there's two values inside of here as well. And I'm actually going to double click this for a second and just so we can zoom in. And let's grab our multiply node and place it up here. So actually, let's move it here. So what I'm going to do here is I'm going to take the output from my dot product and I'm going to plug it into my multiply node. And you can see right now it's brighter, right? So if I move this up and down, and what this is doing is it's multiplying the intensity of that light, or it scales the lighting so we get more bands. So we can actually have an input in here, and I'm going to go ahead and add that here where we have our custom world color, and I'm just going to create a float value. And I can call this something like, I don't know, light scaling or light intensity, right? And I'm going to drag this out, and I'm just going to plug this inside of here. And what this will also do is expose. And then we could set this for now to a value, let's say, of like 1. And you could see that that gives us something similar to what's already there. And then instead of the mode for default, we can have a slider. And we can have it the slider's default value 1, and then the max to whatever you want. You can make this 100 if you want. And then we could save that out. And now when we go back to selecting this object here, I'm going to hit F to focus. On our material, we have a lighting intensity slider that goes from 100 to 0. But we don't actually have it hooked up yet, but it's there, right? It's not hooked up to change anything. All right, so let's add a floor node next. So I'm going to hit spacebar here. I'm just going to type the word floor. And I'm going to connect my multiply node into my floor node here. And let's just kind of move these guys out a little bit. So what does a floor node do? Well, it rounds down each value to the nearest whole number. And this is what's going to help us to create the flat bands that look like a comic book shape. So with this floor connected, and we connected our multiply node here, depending on how our light intensity works, we should be able to get our bands. Now, what's going to happen is we have a little bit of darkness here. So you know what might be better is let me just connect this to our base color here. And we'll go ahead and hit Control S to save this. And let's see how it looks on our sphere. So you can see here that here's our light color, right? It's facing this direction. And we are getting a negative value here. But watch what happens when we increase our intensity on our floor. So I'm going to select my sphere. We have our light intensity here. And maybe we should rename this light bands. But look what happens when we increase this. We start to get different light bands. So if I type a 3 here, you notice we have 3 light bands. We have the light area here, a gray, and then a black color here, or darker gray here, and then into our light band. So this is giving us our comic effect. And so let's go ahead and change this to, instead of light intensity, which was what it was doing before, but we type in light bands. And I'm just going to save that out. And now we have 1 light band. We can do 4 light bands. And there you go, 1, 2, 3, 4. All right, next we're going to add a divide node. And what this does is this divides the results back by the same number. So I'm going to go ahead and hit spacebar. I'm going to type divide here. And I'm just going to connect the output of our floor node into A here. And I'm going to plug it into our base color here. Now what happens is I'm going to save this. You'll still see here that we have our light bands, but now we're dividing it by 2. So our values are back between 0 and 1, and that's safe for us to use in our colors. So if I grab my light color here and I just connect my light band's color to here, and I disconnect it from here, I want you to see sort of the output of that. And we could make this value, keep this value, let's see, at 3 or something. When we save this, you see that now we're back to our we're getting our 3 light band colors because we're set to, and then we're dividing it by our light bands here. And what this is doing is it's actually controlling the intensity, right? Like we move it out this way. So let's keep this connected here to light bands. Let's save that. And if we go to our 3 value here, we've got our 3 light bands, and we're using the same one to control that. Now, if you want to adjust the color here, let's kind of move these up, and then we'll address the issue with our whole thing being like inverted, right? Let's go ahead and grab multiply node. And then what I'm going to do is I'm going to add a color value here. And this color value is just going to be the base color. And I'm going to move this above my light bands. And what I can do is I can multiply this color by our divide node here. And I can plug this in. And when I go to save this, you see it's completely black. But I can actually adjust. Let's leave this at 3. I can adjust this light color to like red. You can see, well, there's my red light band. And it's multiplying. So we're getting a little bit of a greenish tint there, which we can adjust later. And actually, I'm going to select my base color here. And I'm going to adjust its properties. And I want to make it a little bit more powerful light. So I'm going to change it to, let's see, instead of default to HDR. And I'll make the default color just white for now. And I'll save that. And when we go back in here and we adjust this, I can increase the intensity of that. Now, something else I'm going to do, let's see if we can work on flipping this. Essentially the inverting the color here. So what I'm going to do is I'm going to grab my negate node. And what this does is this gives me the negative value. So notice that we're positive here. It gives me the negative value of the values that are being plugged in. So I'm going to take this, I'm going to plug it right inside of here, and I'm going to save that. You can see now it's inverted. And if I move this around, you can see that it essentially is like, kind of move this light too. It's updating with the way our light moves, and we could still get the same good quality with our light bands. So I'm going to make this 4. It's just a little bit less intense because of my HDR settings. So you can see we have 4 light bands there. And I think that's a pretty good introduction to just kind of, kind of creating this different stuff here. All right, so the last thing I want to do is integrate some HLSL into this, right? We've created this, and I'm going to do this by adding a beautiful rim light to our toon shader. And we'll use a little bit of HLSL for this, and it'll create a glowing edge around our object, and it'll make it pop. And this is great for stylized or toon games, right? Because right now we have this going on, and I know our video is getting a little long, and I want to try to get them down to 3 minutes, but there's just so much I want to cover. And if this is for a class, you only have 15 weeks with me. So we have our custom function node here. So what I'm going to do is I'm just going to copy this. Well, let's just add a new custom function here. And then what we're going to do is we're going to rename this node rim light. So let's go ahead and open up our, let's see, graph settings. Let's make this a little bigger. In our graph settings, I'm going to select my custom function. And let's see. All right, let's set our source to string here. And we're going to add 3 custom inputs. The first input is going to be a vector 3. And I'm just going to call it normal WS. And it is case sensitive. And what this is going to do is this is going to take in the input of the surface normal in world space. The next thing we want to do is create another vector 3. And this is going to be the view direction from the camera. So the direction of the camera from the surface. And then the last thing we want to do is create a float. And we're going to call this one, we're going to call this one rim power. And this is going to control the sharpness of the rim light. Okay. And now for our outputs, I'm really only going to have one, and I'm going to call it rim. And it's going to be of type float. Now, inside of here, we need to put in a function name. And then this is going to be, again, the name of the function that's going to be called. And that's why we're getting an error here. And then inside of this, we need to reference all of these different input and output variables by their data type. So for the name of my function, I'm just going to call it rim light float. And then I'm going to type out the calculation. So I'm going to pause the video and just and then we'll come back to it and I'll explain what all of it does. All right. So right now we have a float and it's a single number value and we're naming this variable Fresnel. So right now all you have to think about is this variable is a container. And what this is doing is essentially is in this line of code is we're comparing the surface normal, right? Which is this guy right here, to the view direction, right? And that's this right here, using a dot product. And we talked a little bit about what a dot product is and what it does before. And this is essentially going to tell us whether or not our edge is on, right? And this is the surface facing the camera. And that's what I mean by edge on. And so we have the saturate method here. And what this does is this clamps the values between 0 and 1. And we covered this a little bit in a previous video. And then next we have this power here. And it has like our Fresnel and our rim power, right? We're taking this value in here. And what this does is this sharpens or softens the edge glow. And it stores this in this rim variable here, which is this right here, which is a float value, which is our output. That's this guy right here. And what we get is the result is a strong like silhouette and it fades towards the center. So let's go ahead and create some of these different inputs. So I'm going to go ahead and hit spacebar and I'm going to go to normal vector here. And I'm going to feed this right into here. This is where our normal vector goes. I want to make sure that my space is set to world. So I'm going to go ahead and collapse this so that we can make a little bit more room. The next thing I want to do is I want to grab a view direction node. And we're going to connect this one to our view direction. And then the last thing I want is to create essentially a custom variable in here of type float. I'm just going to call this one rim power. And I'm going to connect that to the rim power section. All right. So the next thing I want to do is I want to be able to control the color of my rim light. So what I'm going to do up here is I'm going to create another color property here. I'm going to move it below base color. I'm going to name this rim color. And again, I want a little bit more control over the intensity. So I'm going to click this little guy here. And sorry, the default here, I'm going to make it HDR. I'll make the default maybe a gray. And I will save that. I'm going to drag this rim color out. And all I'm going to do is multiply that from rim color, and I'm going to multiply that by my rim here. I have an error here. It says, no match. Actually, I think I should move this back here. And the reason for that is this rim method here. Let's see. I forgot to add another. So each one of these need their own output. So right now it doesn't know what this rim is here. So I'm going to add another output here, which I do have here. I have a rim power output here. Here's our power method. And we have Fresnel and we have rim power. I spelled it wrong. I put Powser. There we go. There we go. That should fix it. All right. So how do we add this together? So let's go ahead and actually start doing a couple things. And I'm going to hit Control G on this and I'm going to name this rim light. And then I'm going to highlight this, hit Control G, and I'm going to call this light bands. And then I'm going to take this one, move it down a little bit. I'm going to have an add node here. And I'm just going to add the results of both of these. And I'm going to plug it right into my base color and I'm going to save that. So let's play with this. So now what we get is we have intensity. Let's see, that's our ignition. Okay, let's select this guy. Here we go. So we have our rim power. So if I type in 1 here, and I have our light bands. So we can make it, 3. And then our base color, I'll make it like white so we could see that. And then I can have my rim color here, which could be red. And now you could see if I make this rim power 0, you can see that it's completely controlled. But as I go into this area here, I can slowly start to create a nice little rim light there. See, as I move this out, and there's like almost no, like a very subtle rim light. let's see what, if we go up to, well, let's make sure this is 4. So I need 5 here. 5 could be like very subtle. And then as we bring this down. So what I would do is, to make this even better, is for my rim power, I could rename this rim light power. Or rim light strength or something. I don't know. Power seems a little weird, but rim light, yeah, we'll leave it as power for now. Sorry, I'm recording a lot of these videos at like 3 or 4 o'clock in the morning when my kids are sleeping. So if I sound a little tired or off, forgive me. So anyway, back to here. Let's, come on. Let's maximize this. It looks like it's hiding off to the side. And then let's turn this into a slider. And the default value is, let's see, what do I have it at here? The default value could be like 1.5 or something. If that's like, and then, and I'll show you guys how to turn all of these. We'll create like booleans to turn all this off, but the default value could be 1.5. And then the min could be, let's see, 1.5. And then I think like the max could be 6 or something. And then we'll save that. And then you'll have like a nice slider. Well, we'll make the min 0. And then that way somebody can go, okay, well, 0 is completely, and then it's off. So that's how you add a rim light to your sphere. And we'll tweak all this stuff and make it nicer and better. And then you could change the rim light color. Something else you might want to do, sorry, I know I'm kind of jam-packing this, is take your rim light color and put it together. And then you can hit this and hit add a category and drag your rim light in there. And then just name your category rim light. And then when you save it, it helps your designers know, oh, okay, wait a second, or your artists, oh, this is the rim light parameters, and they can collapse it. All right, that's good for now. Thanks for watching.